Let's obtain the derivative of x raised to the power of x whole raised to the power of x. So we'll begin by considering our function to be equals to y, such that we have y equals to x raised to the power of x whole raised to the power of x. Let this be equation number 1. Now, using the laws of indices, we know that whenever we have x raised to the power of x raised to the power of x, so the exponent gets multiplied. So here we have x multiplied to x in the power. So that means we have x raised to the power of x squared. So that means we have to take the derivative of x raised to the power of x squared. Right. Now what we'll do, we'll use a property of exponents and logarithm, which states that whenever we have the exponent e, this is raised to the power of natural log of a, that becomes simply equals to a. So what we'll do, if we consider the expression on the right hand side, that is x raised to the power of x squared, as a, then in its exponent form we can rewrite it as e raised to the power of natural log of x raised to the power of x squared. Now the reason we have done this, we have another property of logarithm that states that whenever we have log of a raised to the power of b, so that is also equals to b times natural log of a. So here we have x squared as the power of x. So that means we can bring it to the front of the logarithm and rewrite it as e raised to the power of x squared times log of x. So let this be number 3. Now what we'll do, we'll take the derivative of number 3 on both sides with respect to x. So with derivative of y with respect to x, that will be equals to derivative with respect to x of e raised to the power of x squared log x. Now we know that the derivative of the logarithmic function, which is e raised to the power of x, that simply equals to the function itself, that is e raised to the power of x. In our case, we have e raised to the power of x squared log x, and that means our derivative will be e raised to the power of x squared log x. But since we have x squared log x instead of x, so we'll have to use the chain rule. We'll multiply it to derivative with respect to x of x squared log x. Right. That means we have e raised to the power of x squared log x. That will be multiplied to, so here we can use the product rule. We have x squared multiplied to derivative with respect to x of log of x plus log of x multiplied to derivative with respect to x of x squared. That will be equals to e raised to the power of x squared log x multiplied to x squared times the derivative of the logarithmic function. So we have ddx of log x, so that's equals to 1 over x. Right. So that means we have x squared divided by x plus log of x multiplied to derivative of x squared. So that will be simply 2x using the power rule. Now e raised to the power x squared log x, so this is from 3, it's equals to y, or you can say it's simply equivalent to number 1. That means we have x raised to the power of x whole raised to the power of x multiplied to x squared over x will be x plus 2x multiplied to log of x. So finally, we can say that the derivative of our function x raised to the power of x whole raised to the power of x, but this will be equals to x raised to the power of x whole raised to the power of x. So here we can take x as the common factor from both the two terms within the parentheses. So we have x multiplied to 1 plus 2 times log of x. So this is the value of the required derivative.